So today we're just kind of coming back to the whole statistics and kind of finishing what we started with our tests from before, and I think just kind of summarizing the last one here is chi-squared for kind of the first year statistics and the basics that you have to know. So today we're doing chi-squared, so yeah, let's get straight into it. So we've got a question here. Recent research has shown that women who skip breakfast are more likely to give birth to baby girls, whereas women who eat breakfast are more likely to have baby boys. So to test this, we took a sample of pregnant women who already knew the gender of their baby and asked how often they had breakfast. So here, we're not testing any difference in the sense of independent or dependent, because we're not comparing kind of two variables. What we're doing is we've got this nominal data of every day, and some days or never, and we're just taking how many times that occurs, so we're taking a frequency. We're basically taking a tally of these nominal variables, and therefore that's why we're doing a chi-squared, because we're comparing those frequencies and seeing if that breakfast or how often you have breakfast kind of relates to the gender of the baby. So if we jump straight into Jamovi. So another way to think about it, if you're struggling to kind of find out what test you're doing, if you've got something like this in Jamovi where you're told frequency, you can basically assume it's going to be a chi-squared, and you can basically get straight on with it. So we've got male for every day, female, and so on. We've got these frequencies here. You don't need to do any kind of tests of assumptions here. We can literally jump straight into it. So because we're dealing with frequency, we'll go into frequencies. And for this one, we're doing this one here, independent samples, x-squared test of association should be coming up now. Okay, so here we've got rows and columns. Doesn't matter which way around, but as long as you're aware of where you're putting stuff. So we've got the baby gender here, and we're comparing that with breakfast, and then we obviously need to count, so that's your frequency as well. Okay, so we've got our data here. So as you can see, we've got how many babies born were male when the mother had breakfast every day, some days and never, and then we've got the total amount of males here, total amount of females, and the total here, and then here we've got stuff here. So basically what we want to do is, if we follow our kind of guide, the 5-step guide, so if we talk about what test do we need, so here we're doing a chi-squared obviously, then we need some descriptive data as we recall. So what you can do here is, if you go to cells at the bottom and select, so in chi-squared, our descriptive data is going to be some percentages in this case. So if we have our row, that will tell you the percentage kind of males in the row. So of those who had breakfast every day, 38.3% were male here, and that's kind of the percentage of the row. So yeah, we're not really interested in that. But then if we go into columns, so that's more interesting. So here, of those mothers who had breakfast every day, 59.6 of the babies born were male. So you can see here that the kind of hypothesis is favored here. Again, in some days this is again higher, more males were born. However, if then we have the ones who never have breakfast, we can see the females are favored. So we can already get some idea of if our hypothesis is correct. And this is going to be our descriptive data. So here we're going to write something like 59.6% of the babies born were male of those mothers who had breakfast every day. And then we just put an n of 104 for the babies born here. Okay, so then we're going to talk about, what do we need? We need our significance. So here we've got our test statistics, the chi-squared, so you can literally write x-squared. We put a little bracket and degrees of freedom, as we did with our independent tests of difference. And then you just write your x-squared value here. And then obviously we need to test our significance value. So we've got our p-value here, and again we write it. And because this is below 0.05, we can see that the test is significant. So that's the 4 points done. Then we need our effect size, and in this case it's Kramer's V. Yep, you can see here. So we're not worried about this. So as you can see here, in this case it's 0.173, so we can say that's a small sized effect. So right now we've got all the data that we need. So now let's just jump into Word and back, and let's see how we would phrase all this. So I wrote there was a significant association because of this p-value here between frequency of having breakfast and the gender of the baby. And again you can just write x to the power of 2, and then the degrees of freedom with the 2 here, and then your value. And then I just write this represents a small sized effect. So again, it doesn't matter which way around you write all the data, as long as it's all there. So of those mothers who ate breakfast every day, as we saw, 59.6 were born male, compared to 40.4 who were female. So obviously this adds up to 100%, and then the n is just the total here for the column. And again, I just did that for the other two groups of those who had breakfast some days. Sometimes 62.9 and female 37.1, and that was 97 babies. And in the last group it was 42.9 compared to 57.1 in the females, as we saw, and you can see it in this. It's not the best graph. It's also not the most practical to do in Jamovi, so Excel is probably the one for that. So that's basically it on how to do chi-squared. Hope you enjoyed. And then in the next few episodes of Stats Sunday, we're gonna go into more advanced stats, so like regression between groups and ANOVA and stuff like that. So yeah, hope you enjoyed. Hope you have a good day, and yeah, I'll see you in the next one. Don't forget to check the links in the description if you want to try any new trials. And yeah, I'll see you in the next one. Cheerio.